Okay, so you should have just finished the part one video for this lesson, adding algebraic fractions. So if you flip the page, so we've got three more examples here I'm going to walk through, and then three more of a specific type of problem on the very next page. So on this page right here with examples 5, 6, and 7, I'm going to start. I'm going to walk through all of them, but at this point, since you've seen me do several, I would recommend pausing the video and working through these on your own, and then skipping ahead in the video to check and see if you are on track. If it seems like you're not doing it correctly, then go back and watch the walkthrough. So for this first example right here, if I'm looking at subtraction of these two fractions, and I'm looking at my denominators, and I've got 4m plus 2 cubed and 4m plus 2 squared. So my common denominator is going to be this exact denominator in the first fraction, 4m plus 2 cubed. So my second fraction, the only thing I need to multiply by to get that same denominator is 4m plus 2 in the numerator and the denominator to get 4m plus 2 cubed. So my new fraction has 4m plus 2 cubed. My numerator will be the difference of m plus 1. Now that we have the same denominator, now I can subtract m times 4m plus 2. So I haven't really done anything except get a single common denominator. I probably mentioned this in the first video, but when you start simplifying this, and you distribute in the numerator, let me write my denominator. The most common mistakes I see in a problem like this are forgetting that when you distribute this m to both of these terms, you are also distributing this negative. So our numerator becomes m plus 1. So I'm not going to combine like terms yet, just take it one step at a time. And then I'm distributing negative m to 4m. So that's going to be minus 4m squared minus, so negative m times 2, so minus 2m. Now we can combine like terms. So my only m squared term is this negative 4m squared. So that's taken care of. And then I have negative 2m and a positive m. So those two, positive m minus 2m, that's just minus m. And then plus 1. All over 4m plus 2 cubed. At this point, since we just have a quadratic in the numerator, you would want to stop and see if you can factor any more. Hold on. Got it. Okay. But we can actually see that this numerator, the quadratic, won't factor anymore into anything that would help us cancel out with 4m plus 2. And we know that because of this final term being 1. If that factors to something, then its factors are also going to have a final term of 1. So that will not be anything we can cancel out with the denominator. So no more simplifying possible. We do still need to find the domain restrictions here. And since our only denominator for this entire problem was 4m plus 2 cubed or squared, then the only thing we need to worry about is when 4m plus 2 equals 0, because that will cause division by 0. So 4m cannot equal negative 2, divide both sides. M cannot equal negative 2 over 4 or negative 1/2. So here's our restriction on m. These next two examples are complex fraction examples. So we have walked through a couple of these together in class. And our strategy for simplifying these is find the common denominator among the fractions within the fraction. So in this one, the only denominator for a fraction within this fraction is n minus 3. So all we need to do is multiply this whole numerator of n by n minus 3 and the denominator by n minus 3. I am going to just recopy this original problem first. Okay. So we're just going to multiply by n minus 3. Remember, we don't want to change the actual numerical value of our original fraction. So we or multiplying by 1, essentially. My product here, when I multiply n times n minus 3, that's just n times n minus 3. You can distribute, but I would hold off on that before seeing how the denominator turns out, seeing if we can factor anything and cancel. When we multiply n minus 3 by the 1, it's just itself, n minus 3. And then when we multiply that by, now this subtraction, again, this is one of those common mistakes I see. Don't forget about that subtraction. So it's n minus 3 minus, and then n minus 3 times 2 over n minus 3. So the n minus 3's cancel, and we just end up with 2. Then our final step will be just simplifying our denominator. So we've got, again, in the numerator, n times n minus 3. And then n minus 3 minus 2, so n minus 5. And we are already factored, nothing can cancel. So this is our simplified form. And then we just need restrictions on n. Restrictions on n, obviously n can't be 5, but remember that anything that was in the denominator at any point cannot be 0. So that means n minus 3 also cannot be 0. So n cannot equal -3. Number 7 is very similar to number 6. Again, I would like you to try and work through this without me and just skip ahead, see if you do it correctly. If you need to walk through step by step, then rewind and walk through. So here we have another complex fraction. So the only fraction within the fraction is 1 over x plus 3. So that means that is what I'm going to be multiplying the numerator and denominator by. Here, I find it easier to kind of rewrite this and have more working space. So I'm just starting by recopying this problem. Okay. So again, we don't want to change the value of this expression. So we are multiplying by 1 in the form of x plus 3 over x plus 3. In the numerator, we've got x plus 2 times x plus 3. I'm going to leave that for now. Leave it in factored form. In the denominator, this one's a little more complicated. You've got some options here, but the way that I see this is x plus 1 as a group. So this is tricky. You could do x plus 3 times x and distribute the x. Then you could do x plus 3 times 1, and then x plus 3 times 1 over x plus 3. You can do that, or you can just do x plus 3 times x plus 1 as a group. We will multiply that out eventually anyways. So x plus 3 times x plus 1. X plus 3. I need to extend my fraction bar. And then when I multiply x plus 3 times 1 over x plus 3, that just results in adding 1. So this looks a little funky right now because I have factored form in the numerator and partially factored in the denominator, and then there's this plus 1. In order to write this in lowest terms, we need to multiply this out, add the 1, and then see if we can refactor it once this 1 is added into however this multiplies out. So we will need to do a little bit of legwork to keep simplifying. So my denominator is going to be x squared, x times x, plus 3x, plus 1 more x. So plus 4x, and then plus 1 times 3, plus this 1. So plus 4. And now we are looking at a new quadratic after adding this 1 in, which will factor. This is a perfect square trinomial. If you didn't recognize that, that's okay. I'm just going to start by rewriting the numerator. All right, so if I factor this, if you don't recognize that it's a perfect square trinomial, you can still just walk through your normal factorization process. So what multiplies to 4 and also adds to 4? So we've got 2x and 2x. And then we've got our factored form of x plus 2 squared, which is great since we've got x plus 2 in the numerator as well. So we've got x plus 2 times x plus 3 over x plus 2 squared, or x plus 2 times itself. So we can cancel out one of those x plus 2's, and we are left with final simplified form of x plus 3 over x plus 2. This one didn't ask for restrictions, but we should still include them. So we know x can't be -2. And then looking back along the way, we did have x plus 3 in the denominator. So x also cannot be -3. All right, moving right along to our final 3 examples. And these are going to feel a little different because we're talking about word problems involving average rate. So a formula that relates time, distance, and rate that you guys will need to be able to recall. Distance, dt for time, r, is that distance equals rate times time. So that is an important formula that you guys will need to have down. When we move this around and solve for rate, if I want to solve for rate, we would just divide both sides by t and end up with the equation rate equals distance divided by time. So keep that in mind. I want to start with this example and kind of explain the setup. So let's suppose you ride to school on your bike, averaging 10 miles an hour. Then you bike home at the end of the day, much faster, 16 miles an hour, because you cannot wait to get home. So your average speed for the round trip, if we average your speeds for your trip to school and the trip home from school, it is not as simple as doing the arithmetic average, meaning take the 10, add it to 16, 26, divide it by 2, and you get 13. You can't average rates in the same way you average numbers. And the reason for that is because if you bike to school at 10 miles an hour and bike home at 16, what that means is you are riding at 10 miles an hour, which is slower, for a longer amount of time. So time is a factor that we have to bring into play when we're averaging rates, because riding at 10 miles an hour for a longer period of time will weigh the average closer to 10 than 16. So there is a different way of finding averages, specifically when we're finding average rate or speed. What you need to remember is that average speed or rate is the total distance divided by total time. Write this down. Write this down in your notes. Put some bubbles and stars around it. This is an important thing to remember. When you are averaging rates, it is not as simple as adding and dividing by 2. So average rate, you have to factor in the time spent traveling at each rate. So you need total distance divided by total time. So let's break this down. Suppose you bike to school averaging 10 miles an hour and bike home averaging 16 miles an hour. The total distance we don't know. So let's just say the distance from home to school is d. So average rate, I'm going to write down here, leave some space. So leave some space up here because we've got some work to do before we actually calculate average speed or average rate. Total distance, let's just say, remember, distance equals rate times time. So we have 2 different trips, your trip to school and your trip home from school. Trip to school, let's just say you traveled d. The distance from home to school is d. And the rate you traveled on that trip was 10 miles an hour. So d equals 10 times some amount of time that it took you. Then at the end of the day, we're going to write a separate equation for that. You travel home the same distance. So I'm using the same variable d because it's the same distance to school as it is home from school. This time you rode much faster. You rode 16 miles an hour for some other amount of time. So while the distances are the same, these 2 times are different. So we need to make sure we account for that. So I'm labeling those T1 and T2. So T1 is the amount of time it took to get to school. T2 is the amount of time to get home. So when we come down here and start thinking about our average speed, remember, we just need the total distance. Well, if it's D miles to home and D miles to school, then the total distance would be those two things added, which would be 2D. So the total distance is 2 times D. Total time, like I said, we don't know how much time it took to get to school or home, but we do have variables for those. So T1 plus T2. So we know that this is how we're going to calculate our average speed, total distance over total time. Problem is, how do we simplify this? Because right now I have 3 different variables. But if we look back up at our equations here, we know that D equals 10 times T1 and D also equals 16 times T2. So we should be able to solve for T1 here simply by dividing by 10, and we can solve for T2 as well. Both of those will be in terms of the variable D, and that will allow us to move forward calculating our average speed. So again, I have T1 plus T2, so let's just solve for T1 up here. T1, you're just dividing both sides by 10. So T1 equals distance over 10. Same thing here with T2. Divide by 16 on both sides, and we get T2 equals distance divided by 16. So now, when I come back down here, instead of writing T1 plus T2, now I can substitute in T1 is D over 10 plus T2, which is D over 16. So now we're just looking at a new algebraic expression, which we just spent time practicing how to simplify this. So we have a complex fraction, fractions within fractions. We still have a variable and we're trying to solve for average speed, but something great will happen pretty soon and those D's will cancel out. So right now I've got fractions within fractions. So to simplify that in a single step, all we need is the common denominator between our 2 smaller fractions. So we've got 10 and 60, or 10 and 16. While those could easily have a common denominator smaller than their product of 160, I like to just use the product no matter what, even if there is a smaller common denominator, because using their product makes simplifying a little smoother. So I'm just going to now multiply numerator and denominator by my common denominator of 160. So when we do this, 160 times 2D, that's 320 times D, divided by, now when I multiply the 160 by D over 10, since 160 is the product of 10 times 16, then 160 over 10 will simplify. The 10 over 10 will cancel, and I'm left with 16 times D. Plus, and then the reverse will happen when I multiply by D over 16. The 16 over 16 will cancel, and I'm left with 10 times D. So now our complex fraction is down to a simple fraction, 320D divided by 26D. And now, even though we still don't know what that distance traveled to and from school is, it doesn't matter because they are factors in the numerator and denominator, so we can cancel them out. And we are left with a value of 320 divided by 26. So about 12.3. Don't forget, we are finding average speed. So this is in miles per hour. We know that because we were given distance in miles. I'm sorry, we were given rate in miles per hour in the original problem. So now we know your speed, average speed was 12.3 miles per hour. And I'm going to go back to what I said in the beginning of this problem. It is not as simple as just simply taking the arithmetic average of 16 and 10, which is 13. We remember if you biked at 10 miles an hour on the way to school, you spent more time traveling at that slower speed, which means the average rate will be weighted toward 10. And that's why we see 12.3, which is actually less than the arithmetic average of 13. Okay, so that is a hopefully very clear walkthrough of average speed. I'm going to walk through these two more, 9 and 10. After number 9, I would encourage you to pause 10 and try it on your own. And if you need to go back and walk through with me, then do that. All right, another averaging rates here. Find the average speed for a trip where the first 100 miles are driven at 60 miles an hour and the final 250 miles are driven at 70 miles an hour. Again, we've got two different rates. We can't just simply add them up and divide by 2 because we're traveling. First of all, our distances are different this time as well. So that also plays a factor in here. But we're always starting with that original relationship that I emphasized here, distance equals rate times time. So distance equals rate times time. We'll set up two equations, one for the first 100 miles, one for the second 250 miles. And then we will find average speed by dividing total distance divided by total time. So again, if this isn't on your paper, average rate, total distance over total time, get it down because you're going to need to refer back to that. All right, so we've got the first set of the first leg of the trip, distance equals rate times time. First part, we've got 100 is our distance. And we travel 60 miles an hour, so that's our rate for some amount of time. Then the second part of the trip was 250 miles, traveling at 70 miles per hour. So 250 equals rate 70 times some other amount of time. So we do need to make sure we use different variables for T1 and T2. This is a little bit different because our distances are not the same, but that's okay. We know the average rate is still going to be total distance divided by total time. Well, our total distance is just these two distances added. So we've got 350. Total time, we don't know yet. But again, just like in that first example, we can solve for T1 and T2 and substitute them in and then calculate the average rate. So T1, we're just going to divide both sides by 60. So T1 equals 100 over 60, which we can simplify 10 over 6. And we can simplify again. So let's get this as simple as possible. So we're working with as simple of fractions as possible. So 10 over 6, both divisible by 2. So T1 is 5/3. T2, we're going to get by dividing both sides of this second distance equals rate times time equation, divide both sides by 70. So we get T2 equals 250 over 70, which simplifies to 25 over 7. So these are T1 and T2. So down here, when we want to find our average rate, we've got 350 divided by 5/3 for T1, 25/7 for T2. This one's nice because I don't even have a variable here. We just need to simplify this. I'm still going to do it. I know you guys can type this into your calculator, but I'm still going to do it just kind of by hand, applying what we've been focusing on with these fractions. So we've got complex fractions, and my two smaller denominators of the fractions within the fraction are 3 and 7. So I'm just going to multiply the numerator and denominator of my larger fraction by my common denominator of 21. So 21 times 350 is 7350. And then when I multiply 21 by 5/3, the 21 over 3 will simplify to 7. So it'll really be 5. I'll be left with 5 times 7. Then when I multiply 21 times 25/7, again, the 21 over 7 simplifies to 3. And then I'm just multiplying that by the 25. All right, so I've got 7350 over, again, we're not dealing with any variables, so this one's a little faster, a little smoother. So we've got 35 plus 75, 35 and 75. And we've got 110. So there we go. We've got our average rate, 7350 divided by 110, about 66.8 miles per hour. 66.8 miles per hour. Again, we know like your answer should always make sense. So we traveled at 60 miles an hour for part of this trip, 70 for another part. The average rate is closer to 70 this time. You traveled that at 70 miles an hour for a longer distance and therefore a greater amount of time. So we do see this average weighted towards 70. All right, one more. This one is you're given a little bit of a different setup. So if you want to pause now and just see if you can get it set up correctly, since this is something you guys will need to be able to do on your own, obviously. And then try and work through it. Or if you get to a certain point, maybe after the setup, and you're like, okay, I got it from here. Just pause it at some point and see if you can get through this on your own. All right. So we're talking about an airplane averaging 350 miles an hour for 70% of the trip. So this is a little different because our distances are given by percentage. And then 400 miles an hour for the remaining 30% of the trip. Just a reminder, we are always going back to distance equals rate times time, and average speed is total distance divided by total time. So for the first 70% of the trip, what's our distance? Let's say the whole trip all together is D, then the first 70% of that is just 0.7 times D equals. So for that 70% of the trip distance of D, you averaged 350 miles an hour for some unknown amount of time, T1. The second 30% of the trip, so 0.3 of the distance in total, was traveled at 400 miles an hour for some other unknown amount of time. So when we are averaging here, we'll get our average rate equals total distance. Again, this time total distance, we've got 0.7 of the distance plus 0.3 of the distance. So our total distance in this one is just D. Total time, T1 plus T2. So now we need to go back and solve for T1 and T2. So we've got T1, we'll just divide both sides by 350, 0.7 D over 350. T2, we're dividing both sides by 400, so T2 is 0.3 D divided by 400. So now we can go plug those T1 and T2 into our average rate formula, distance divided by 0.7 D over 350 plus 0.3 D over 400. This one looks a lot more like the very first example because of the distance in here. So we can, again, we've got complex fractions. Our smaller denominators of 350 and 400, again, those probably have a common denominator that is less than their product, but I still prefer to use their exact product because simplifying gets a little bit easier. So that's 140,000. So I'm going to multiply both numerator and denominator by 140,000. Obviously, in the numerator, we are just left with 140,000 times D. In the denominator, so because 140,000 is the exact product of 350 and 400, when I multiply this by 0.7 D over 350, the part of 140,000, that's the 350, will cancel out. And I'll be left with 0.7 D times, again, the 350 will cancel out, and I'll be left with 0.7 D times the 400 plus, and then I multiply 140 times 0.3 D, and the 140,000 divided by 400 will simplify to 350. So now we've got, it's not very fun to have decimals within fractions, but it all cleans up very nicely. So we've got 140,000 times D. And then down here, we've got 0.7 D times 400. So 0.7 times 400 is 280. We've got 280 times D plus 0.3 times 350. So 105 D. So we end up with 140,000 times D over 385 times D. So some of you probably realized already in this first step, these three terms in this fraction all have a product of D. So we know that those are going to cancel out eventually, and we see that finally happening here. And then we can just compute 140,000 divided by 385. And we are left with finally our average rate of 363.6. Don't forget, we're talking about airplanes traveling in the air. So it's a big difference between our answer up here of 12.3 miles an hour. So your answer should always make sense within the context of the problem. So when you're done with one of these problems and you get your answer, just make sure you're thinking about whether or not it makes sense, miles per hour. Okay. All right. So that is the end of 5.4, adding and subtracting algebraic expressions. Don't forget about this important relationship of distance equals rate times time, and how to calculate average speed by dividing total distance divided by total time. All right. That's it for now. I'll see you soon.